In this video, we're going to take a look at a new way for processes to communicate, something called a client-server system. And this maybe is going to be familiar to you guys. So moving forward, let's take a look actually at the diagram at the top right. So here we have basically two computers. So here I have one labeled as host X, another one called web server. And so what we want to talk about here is basically a notion of I have two different computers, how can they talk to one another? One way to do that was something called a socket. A socket is really a name for an endpoint of a connection, right? So a connection, right, maybe is this line here, right? Or maybe we call it like a communication link. A socket is its endpoint. The endpoint really has two parts of it. First, it has this overall number here, right? Which is going to be basically four pieces, right? Separated by periods, by dots. That's an IP address, right? That's probably going to be familiar to you. The second part, right, is this over here, which is separated with a colon, right? Which is a little bit smaller number, right? There's no separators in there. That's a port number. Okay, so these are kind of unique identifiers. That IP number is generally going to be some sort of a unique identifier for your computer or for our computer on a particular network. So if you're logged onto the internet, your computer of course has an IP. If you want, you can actually go to a website, right, that says, what is my IP, right, and look it up. If you're on a network, right, somewhere else, right, you're going to have an IP, right, that's going to be local to the network itself. Point is, it's some number that identifies your computer. Then the little port number there, right, these little things here, right, I'm circling them just as an example, right, first one over here was 1625, the other one is 80. Those are kind of like specific mailboxes, if you would, right? It's like I'm sending information to a computer, I want to send it to a specific, part of the computer. So these two things, right, our IP and our port kind of together define a socket, right? They define kind of an endpoint for communication. So here we have our two endpoints, right? So presumably, right, there's a socket available, on the server, there's one available on the host, right? And those are really forming a connection, right, to let data be transferred from one location to another. Okay, now as a quick note here on the slides, these numbers are kind of, well, they do mean something. The IP numbers have a specific breakdown. If you take a class in networking, they'll go through them. But the kind of the different little areas in there, right, kind of mean something different. And depending kind of on what is your network environment, they may look a little bit different. So sometimes you'll see a lot of them begin with, for example, 192. If you look at, for example, your kind of local network, right, things may look like that. They have just kind of a certain pattern behind the scenes. There's also a pattern behind the scenes for ports in that those port numbers have some semantics attached to them. For example, that port number 80 in the example up on the slide, that's actually the port for basically for hosting a web server, right? So if you want to serve out a web page, typically it's going to be served over that port 80, right? So some of those ports basically have some meanings already associated with them, right? This port is out there to do this, right? And then above a certain range, those are going to be basically ports that are free for everybody to grab, right? So a random program on your computer can listen at a port, right, and ask to get data there. So some of them are fixed, some of them are kind of variable. So on the next slide, basically what we're going to do is we're going to walk through a little example of how we set up ports, right, in terms of Java, right? And we use them basically to send a simple string from one location to the other. For the purposes of this demonstration, we'll take a look at something called TCP, which is basically one of the two protocols, right? There's TCP and UDP. There's two different protocols basically for moving information across, or between computers. The main difference for now, and we may go into these in more depth later on. The main difference somehow is the UDP is basically it doesn't have a confirmation there, right? It's not really a safe protocol. It's basically the idea of, I'm just going to send some information in somebody's general direction, and I'm going to cross my fingers and hope that they get it, right? Maybe it is lost. TCP, right? There's kind of this idea of, I'm going to verify, right, that they did receive the information correctly, right? That it is right, the right stuff that made it across. And so you can imagine, right? TCP basically is more reliable, versus UDP somehow is faster, right? Because you don't have to wait to get confirmation that something worked out. So for now, we'll just look at TCP. So here we have some Java code to talk about. And this is going to be relatively straightforward. Fortunately, Java has a very rich API for dealing with these connections. So we'll start over on the left. The left, of course, is the server side. So here I have basically what I call a date server. So the idea is that this will be a class that can let people connect to it, and it'll send across, what is the current date, right? So it's basically just transmitting a string of text. Maybe we can even think of that as being a little bit more generic, right? It's almost as if we're just sending a string of characters, meaning a string of bytes, right? So it's really a generic way to send information across. Here, just in terms of what our example is, right, we're going to use that in order to send, a specific date, right, that's encoded as a string. Okay, so moving down, right, we have some boilerplate stuff, right, we have our main. Obviously, here's some includes here. We don't really need to focus on those, but obviously we need to bring in some stuff in order to have access to the network classes. The first new line in here, right, which is the new stuff, is this server socket line, right? So basically what server socket is it's going to be a class that basically mimics the creation of a socket, right? So a socket has an endpoint and a connection. It basically has, associated with it an IP and then a port. Here, there's not really an IP number. It's kind of just assumed that, the IP we're looking at, right, is us, right? Is whatever is the IP it's assigned to the computer this program is running on. And then over there on the right-hand side, we have that 6013 number. What that's representing is the port number, right? So that's kind of specific, I'm going to listen for data here, right? I'm going to attach myself to this port. Again, just think of ports as being like specific mailboxes, right? So it's like you picture, right? Maybe there's a bunch of apartments, right? And you have a whole bunch of apartments, all the same address, right? Same IP. But each of those apartments, right, has a different, apartment and, a number associated with it, right? To direct it to different people. Same idea here, right, with that port number, right? So how do we direct it to a certain program? Okay, so inside what we have is basically our while loop, right? After we create our socket, which basically means we're going to be set up and waiting for messages to be received, waiting for someone to start a connection. Listening for it is the proper term. We'll have basically this loop in here to go and service those requests, right? Listen for people that want to talk to us and give them the information that they want. So in here, right, I have basically the socket accept, right? So I'm going to sit here and basically just wait for someone to come along and ask to connect to my, to my socket, right? So I'll sit there and wait. Once I have that, right, then what I'll do is I'll basically get kind of a connection from them, right? What I want is some way to write characters to them. And so I can actually, because this is Java, right, basically that client that connects will implement basically one of the stream classes, right? And from that, right, basically we have this idea of an output stream, right? We're going to get that output stream, right? And that output stream, right, once I have that stream, that's really just an interface behind the scenes, then I can just treat it as if I'm going to write text to it, right? Same as if I'm writing text to something like a console window, right? It's not too much different. So I'll get that output stream, I'll wrap it in a print writer, right, which you guys maybe have seen before. It's basically just kind of a nicer way to write strings, right, to a stream, right? A stream normally think of in terms of, it's mainly just transmitting bytes. Here we want a little bit higher level, we want to send across a string. And then we do it, right? So we have basically our println, right? Our println, right, is happening on that pout variable, right? But that means we're going basically to that print writer, right? We're doing a println on it. And then we're sending it a message, right? We're sending it the date, right? That we're basically generating locally, right? So locally I figure out, from the server's end, what date is it, right? Make a string out of that, and then basically write that to that connection that I open, right? Write it via the print writer, write it via the stream, right, to that socket, right? So I've sent data across. So there we have it, right? So that's basically how your server works. On the other side, we have the client, right? And the client has some standard stuff, right? Again, we have packages being inserted, right? We have our classes being defined, our main, so on, right? And then here, where our socket is a little bit different. So here what we're doing is we're specifying kind of the IP. So we're specifying 127.0.0.1. That actually has a second name for it. It's actually called localhost. Basically what that is that's kind of shorthand for connect to yourself, right? So these are actually programs that are meant to run on the same computer at the same time. Even though they could run over a network, right? They're using that IP number, right, to specify different computers. For now, they're kind of just set up to be tested on one particular machine, right? They're both running the same place. And so that's what localhost basically is going to signify. It's going to signify that the client is going to connect to itself. Okay, port number obviously is the same. Now we have the same process. We basically make a stream right out of that connection, right? So that we can deal with it using kind of our normal operations. So you create an input stream, right, instead of an output stream. And then we wrap that with a buffer reader, right? So the buffer reader, again, is going to be a nice way for us to send information to that stream or get information from that stream. Once you have that, right, basically we have a loop, and what we're going to do is we're going to continually pull that source, right? So we're going to keep on doing our little read line operations on our buffer reader and just wait, until we can't get any more information from it, right? So we'll go line by line, pulling out data, pulling out data, pulling out data, and printing it out as we go along. Eventually, right, I'm not going to have any more data, and so I'll close the socket, right, and basically loop back up, right? I can, not loop back up. Basically, I just finished, right? I can if I want, run the program again, right, to get more data, but from this standpoint, right, basically we've pulled all the data, it's good to go, and we can move on with doing other stuff. So again, simple example, right, of a client that connects to a server to read strings. Really just, a stream of bits or stream of bytes. So in addition to socket connections, there's a couple other ways that processes can communicate with one another. One of them is RPCs. Here on the slide, right, remote procedure calls. The other is pipes. I'm going to talk really briefly about RPCs. It's not going to be long. I'm not going to show you guys code. I just want you to have a vague idea of what this is. So the idea of a remote procedure call is basically to say, I have some server somewhere, and this server, right, has basically some functions that are available, right? And a client can go and basically remotely call those functions, right? So remote procedure call. Generally what happens, right, is that there is some sort of like a stub API that's exposed to the client, right? So basically it's like there's a library, and this library, from the client's point of view, right, from your program's point of view, it looks like you're just calling functions. But really, right, they're really just stubs, right? And those stubs take your different arguments that you pass to those functions, and they marshal them into this little packet of data, right? And this packet of data gets sent across to the server. On the server, there's going to be something called a matchmaker, which is basically going to say, okay, you know what? I see someone's asking me to do something, right? They want me basically to make a function call. They've given me all the parameters packed together into a little data packet. I got to find somebody on my end that can actually perform that operation, right? And so then they do that, right? They find them, right? They match them up. They give them the arguments. Some data processing happens, and then you return a value, right? And that value gets, again, packaged again, right? Returned to the client side, right? and that it becomes basically unmarshaled, right? You basically take that thing and unpack it and returns value to the person who called it, right? So again, the idea is, right, that from the client side, you're basically just acting as if you're calling a function, right? But really behind the scenes, it gets packaged up and sent somewhere else to be completed. So that's the basic idea of an RPC, or remote function call, remote procedure call. One little note there at the end, right, is this idea here, and this is kind of just a safety thing just to mention off to the side. There's kind of this issue of sometimes you do RPC calls and the problem is, oh hey, that call does something, it changes something somewhere. And so if there's a network issue, there's a problem with either maybe it doesn't happen, right, or maybe it gets repeated, it happens twice. That kind of is an issue, right? And so we need to make sure when we implement RPC systems, if there really is some sort of a back and forth, some flag that's getting passed, say, oh yes, this did go across, right, it did get executed, right? I don't need to execute it again, right? You don't need to repeat yourself, right? It's already done, you can move forward. So you do need to be a little bit careful with these things because you're basically allowing somebody else to have control over the code that's making up your program. The last mechanism we have is something called a pipe. So pipe basically, it's going to act a little bit like a kind of when we see it in program code, it'll act a little bit like a magic variable. Somehow it's the idea of I drop data in on one end and it comes out on another end, right? Somebody else. So I have two processes connected by a pipe. I can do things like writes into it, and that kind of implies that you are able to do reads on the other side. So it's kind of you may have seen this before, right? There's even kind of a pipe command in Linux, right? Which is basically kind of shorthand for, oh, hey, take the output from one thing, right, from one process and pass it to another, right? It's kind of related. There are several variations of how pipes can work. There are considerations, for example, do I want process 1 to send a message to process 2, and then process 2 can send it back, or should it just be one way, right? So there's this idea of directionality, right? So maybe I want things to be unidirectional versus bidirectional, right? How information flows. There's kind of something related for duplexing, right? Also the thought, right, is that maybe not only is there a direction involved, but do you want to maybe allow them to both simultaneously work, right? Or does only one have to go at a time, right? That kind of is, how does your buffer work? Is your buffer kind of exclusive, right? Only one person can write to it and then one has to read to it, and then if they want to send a message back, they have to wait till it's done? Or do you have kind of two buffers side by side, right? So there's kind of this notion of directionality plus do I allow them both to go at once? Both those kind of, play into the next thought there, right? So our process is asymmetric, right? So based on, these processes, how they relate, right? Is it appropriate to be, unidirectional or bidirectional, right? That depends on, what the processes are intended to do. Pipes can also be either networked or local, so basically they can be between processes that maybe are on different machines, right, or at different IPs, or they can be, in the same system, right? They can be basically between, two children of a process that is forked earlier on, right? Something like that. So I can use it kind of in different scenarios. So there are two types of pipes, basically an ordinary pipe and a named pipe. Ordinary pipes basically just exist in your program as a variable. And so that's used typically when you have a process running, right? You're going to do a fork. And so if you're going to do a fork, right, both those processes are going to basically inherit, right, or have access to that one variable. And so that's what we'll call basically an ordinary fork, right? We have one variable that kind of is shared between two programs. The other idea is of a named pipe. And so that's basically saying, oh, we're going to stamp a name on it, right? So we're going to basically give it something that looks like a file name, because if I do that, basically any program in my system, right, any process running, if it asks for that name, right, it's going to be able to access that particular variable, right? So it's kind of a more global way to announce that you have something available. So that will need only though for the case of different processes on different machines or that are unrelated wanting to access the same pipe. So now we're taking a look at this, let's take a look at how we use an ordinary pipe in terms of the C libraries. Okay, so here's a really simple example. All that's going to happen is we're going to pass a little string message from a parent process to a client process, or to a child process. So starting at the top, right, we'll kind of read through this. This is in C, right, so I have basically just one program, right? Fork, basically, you have to fork, right, and then an if statement to define, is something happening to the parent versus something happening to the child. It's not like the Java example earlier where we had two different programs. It just is one thing here. So going through, we need, of course, our standard includes, right, in order to bring in all the functionality that we want. Then we have three defines here, right? And so these defines, I guess we'll talk to them for just a second. I'm not going to go into too much detail on this in this example, right? Mainly because it's simple, also because we're not really going to need it for much right now. But I need to give you kind of a flavor, right, for how the API looks. But anyways, these defines, right? So the first one is buffer size. So that's basically controlling, the size of your buffer, right? So if you basically need a place to store your message temporarily, right, during transmission, right, how much space you're allowed. So we're going to go ahead and create that, right? Just going to say it's 25, right? That's going to be kind of my largest message that I could write, the largest message that I could read, right, over that pipe. And then I have basically my second two variables here, right? Read end, write end. And so that's actually going to kind of relate to this over here. There's a variable over here called FD. FD it stands for file descriptor. It ends up being this little array, right? It just has two elements. And the first index basically is a special ID number for basically your read descriptor. Second one is for your write descriptor, right? So these two indices here, right, this little mini array, are pointing basically to a read end of a pipe and a write end of a pipe. That's how it'll end up looking. And we're just using it there, read end, right, basically to be, we're using it there and we're binding to 0 because the 0th index of the FD array will end up containing the ID of the file descriptor for reading. Same thing for write, right? So we just want to say instead of using that 0 and 1, we want to use the keywords, read in or write in, right? That's what we're trying to do there. So jumping down into the heart of the program, we have basically two variables here, right? We have our write message and our read message, right? Both of these are character arrays, right? And initially you can see that we're populating our read message, right, with all the characters we want to transmit. The read one, we'll just kind of leave it alone because it will end up being where we store stuff. Of course, you have the file descriptor, so that's going to be effectively pointers to say, where do you put data, where do you get data from, right? And then we have our PID because we will be forking at some point. First real piece of code right here is basically this pipe command. So the pipe command is basically going to go and create this kind of pipe reference, right? So this pipe file pointer, right, or file descriptor, right? Basically the little magic number that says, okay, yeah, I put data in here, and that implies it'll come out somewhere else, right? So I'll do this pipe of FD. And that populates, right, this array over here. So the first index has basically the magic number to read, the second number has the magic number to write, okay? Those really are just magic numbers, right? They're file descriptors. They're pointers to say where to go find something. If there's an issue, right, we'll end up, exiting out. So that's fine. Once the pipe has been assembled, our next step is going to look at forking, right? So we want to create a fork, basically make sure I have two processes side by side. So this is very typical. And then I have, of course, my two branches, right? So based on that, result returned by that fork, right? Maybe I'm in the child, maybe I'm in the parent. How do I figure it out, right? Oh, I figure it out based on the PID, right? So if I have PID greater than 0, that implies I'm in the parent, right? So that's this code here. If I have PID that is equal to 0, that implies I'm in the child. So let's take a look at the parent first. So if I'm in the parent, basically I'm going to make life a little bit safer for myself by closing the read end of the pipe, right? So I'm not going to need to do reads as my the parent. The parent's job is just to put data in the pipe, send it away, right? Then the child will read it. So to make sure I don't mess with that, right, I'll basically close off the read end. Once I've closed off the read end, then I can go to the write end, right? And this write command, the write command basically is going to it's going to write basically some data byte by byte to some device. So write takes as its first argument, right? This thing here, it takes basically like a device ID. I think it's a device ID, so that's a device descriptor, I guess. Descriptor, something like that. So that's kind of the first argument there. And then basically what we have here is basically a source of data, right? So this is where stuff comes in, and this is number of bytes. So those are kind of our three arguments there. And so basically what we're saying is take all the contents of that string, throw it at the pipe, right, in the direction of the right end. So hopefully it pops on the user's end, on the client's end, or the child's end. Over here, last line here is close because once we're done with the right end, we're good to go, right? So we can kind of close it off. Now the child, it's similar, right? Here we're going to start by closing the right end because again we want to be safe. The child doesn't need to write, it just needs to read, and then we do a read operation, right? And here, right, the arguments are effectively the same, right? So this is again our first argument here, right, is basically our device ID, right? Here it's going to be a file descriptor of a pipe. And then over here, right, basically this is our variable we want to take information from. And then over here, right, this is basically our buffer for how many characters do I want. So that should be pretty much the same as our initial write command. We do that, right, and all of a sudden our read buffer has been populated in the child and sent out contains text, and so if we do a printf on it, well then it'll display out the message, it'll display out greeting, right? And then at the end we can basically close our read end of that pipe. So over here it's pretty straightforward, right? Again, the idea is we kind of have this magic number, right, that represents this thing, right, that can throw bytes at and that can take bytes out of, right? We use that appropriately on the server, on the parent's end, child's end, right? We'll have our data flow from point to point.